two block system. And how to solve two block system questions? Consider that there is a floor and there is one block there A, and there is another block B whose mass is A, let it be whose mass is B, mass MA, mass MB. Now on one of the block force will be applied, let it be force given on A, F force is given. Question number 1, how to solve this? Three steps I will tell you. Step number 1, first check is this force is enough to move the block, first of all. So what is the minimum force required? Minimum force required, this is let it be applied force to move this block, to start moving. Here let it be friction, mu A is the friction. Now consider the whole system as one block. Now mass is A plus B, friction will be, so F minimum require is sorry, F is equal to mu N. Here downward force is mg, upward force is normal. Mu is the coefficient of friction given between the block A and ground, and N is mass of A plus mass of B into G. So this is the minimum force required to start the motion. If any time minimum force is required, if the question is, then applied force, this minimum to minimum, this value you should get. If it is more than this, then the block will move. If F applied is less than F minimum, both the blocks will be at a rest. Case 1 you check. After that, if the applied force is greater than F minimum, then step number 2 what you do? Step number 2 what you do? Take the only block on which force is not there. Now here applied force is there, on block B force is not there. But how the block will move? If you pull this block A, both block A and block B will move, correct? Now who is pulling this? There is a friction between A and B. Friction definition is friction acts opposite to the relative motion, intention of motion. Now if you see, block A is moving front and now you are in block B. For friction it appears that, now if you are in block B, imagine now there are two buses are there, bus A, bus B. Bus A is moving front, train A is moving front. It appears to us in bus B that we are moving back, because like you see, if you are here, if you feel that we are moving back, friction do not like it. The relative motion between A and B is block B is moving back, so the friction will act front. So this friction pulls block B. So find out that. So take only block B and friction is pulling it, and this creates some acceleration in it. Find out the maximum acceleration possible with the friction. So F max formula we know. So F maximum formula, mu into N. Here mu is the coefficient of friction between A and B, okay, and N normal force. This is mg, mass of B into G, and this is the normal force. So you can say mass of B mu into mg, mass of B into G. So this is the maximum friction possible. This maximum friction produces acceleration in it. So F net is equal to ma, you can write. So mass of B into acceleration maximum is equal to mu into mass of B into G. MB you can cancel. So you get the maximum acceleration of block B possible. And this is the maximum acceleration of the system, I can say maximum acceleration of the system. Both will move together. Yes. What is the maximum force? Then F maximum I can put such that A and B together move. Now A and B moving together. Then you see both the bodies move together, means A and B together you take. So F maximum possible is MA, F net is equal to MA, because you are applying this force F, and this I want maximum F applied force is M into A. Okay, and there is a friction acting. So take it. Here is the maximum acceleration possible. We know the maximum acceleration we have already found. This is the maximum acceleration. So we want this F max. Apply F net equal to MA. F net is, see, right side force is F max. Always remember F net formula, right side force minus left side forces, because body is moving right side. F maximum minus friction is equal to MA, total mass into maximum acceleration we already found here. This is total mass. So F maximum possible is the friction between them plus M into Max. This friction we already found here. Maximum friction. Friction formula. See, this is the friction, right? F maximum possible. This is the maximum possible. You calculate this value, and this is the maximum force you can apply on the block such that both the blocks are moving together. If by chance, now what is the conclusion from here up to now? Up to now the conclusion is, if you are applied force less than this F minimum, then both the blocks will be at rest. And if your applied force is greater than F maximum, then only A will move and B slips off. And your applied force is between these two, means it is greater than F minimum and less than, if your applied force is less than F maximum, then both will move together. Both will move together. Now, this is the case we missed. If F applied becomes greater than F max, then how the situation will become? Now the situation becomes A is moving, B is slipping. So on A, so B is slipping. Slipping means what? A is going front. The friction do not like. Then two frictions will act. Friction because of B, and here is the friction because of the ground, and this is your F applied. Okay. So this both the frictions you should consider when you are calculating this case, where applied force is greater than a maximum. Let's solve some questions. Let's try to understand with questions. Block of mass 3 kg rests on another block of mass 7 kg. See, there is a mass, there is a 7 kg block upon which there is a 3 kg block, right? So this is 3 kg and this is 7 kg. The coefficient of friction between A and B, here, this is A and B. This is A, right? This is B. Here, this here mu is 0.4, and the coefficient of friction between B and the horizontal floor is 0.55. Which this is the floor. So we have a floor here. So this the coefficient of friction between them is 0.55. Up to here the question is clear. Okay. Find the force of friction between between A and B when the horizontal force of 50 Newton is applied. Chalo, 50 Newton force is applied on block B. Means you are pulling the block B with a 50 Newton of force. Now I explained you 3 steps. Just check with step number 1 whether the system is moving or not. For that, what we need? We have to consider the entire system as one, correct? Now here the total mass is 10 kg and the coefficient of friction we know mu is equal to 0.55. So how much is the frictional force maximum? It is mu into n. Mu value 55 by 100, it will be easy for me. And the downward force is mg, upward force is normal, so I can say normal is equal to mg. So 55 by 100, mass is 10, g is 10 already given, yeah, g value 10 given, so 100 cancel. So the minimum force required is 50 Newton to move the block, but the applied force is 50 Newton, means the two blocks are in rest. That's it. When the blocks are in rest, the friction between them is zero. Option A is the correct answer. Thank you. System of two blocks, masses 2 kg and 8 kg are placed on a smooth table as shown in the figure. Means here friction is zero, right? Coefficient of friction is zero. This is 8 kg and this is 2 kg. And the coefficient of static friction between the two blocks is 0.5. Means here the coefficient of friction is 0.5. Fine. Next, the maximum horizontal force that can be applied to the blocks, to the block M, such that they both move together. Okay. So the question is on both the blocks should move together. So I explain you three steps: step 1, step 2, step 3. Step 1 is for finding minimum force, and step 2 is finding the for maximum force. So directly I will go for step 2. So in step 2, what we will do, we will take the block and which force is not there, only friction is acting, and according to that our 2 kg block. So this is the 2 kg block and which only friction is acting. Friction is pulling the 2 kg block. Now only friction is pulling the 2 kg block only. So choose that block. So I have chosen that block on which only friction is acting, the 2 kg. How much is the friction? F max is equal to formula mu into n. N is downward force mg, upward force normal, so n is equal to mg. Right now mu value given 5 by 10 and m value is 2, g value is 10. Oh, 49 then is 9.8 they take, 9.8. 5 ones are 1, 5 twos are 2 to cancel. So maximum friction acting is 9, right? Then I can find out the maximum acceleration of it. That's a, so this is equal to m into, this is equal to m into a max, that is the maximum acceleration of the system. And m value given, m value how much given? 2. This is 2 kg block. So I can say a max is equal to, a maximum of the system is 2u transpose divided by 2. It becomes 4.9 meter per second square is the maximum acceleration of the whole system. So now you see the whole system is there. This is step number 3 I explained in the theory. 10 kg block is there. I'll suggest you the theory video, just go with it. And 10 kg block, the total system you have to take, and the maximum acceleration possible is 4.9 meter per second square, and this is the force F is acting. There is no friction, the friction is 0 here. So directly I can take F net is equal to ma. So there is only force acting is capital F is equal to ma. Mass is 10, acceleration 4.9. So answer 49 Newton required. This much 49 Newton force is required to move the block. Maximum force that is possible. More than 49, what happens? 2 kg mass will slips. Thank you so much.